Hello, and welcome to this video on reaction rates. Today we're going to study reaction rates using carbon-14 as our sort of example reaction. This is a nuclear decay reaction, which is a little different from some chemical reactions, but we can still study reaction rates in the same way. So let's get started. The first thing we want to talk about is the order of the reaction. So this is a nuclear decay reaction, and all nuclear decay is first order. And so this means that the rate is directly proportional to the number of carbon-14 atoms. And it also means that we are going to have two different rate laws that apply to this. So we have the differential rate law, the differential rate law says that the rate of change of the carbon-14 atoms is equal to the rate constant K times the number of carbon-14 atoms. Now we could also study the rate of formation of nitrogen-14 atoms, and it's going to be actually the exact same equation, except without the negative sign in front of the negative sign in front of this. And we also have an integrated rate law. So the integrated rate law says that the natural log of the number of carbon-14 atoms at some given time is equal to the natural log of the original number of carbon-14 atoms minus the rate constant K times the time that has passed. Another thing we might want to study is the half-life, and we call that T1/2. Now this for carbon-14 is about equal to 5,700 years. So before we continue ahead, the number of carbon atoms is going to depend on whatever sample you're looking at, but we do want to, and so does the time, but we also want to know what this K is. So K for first order reactions is actually related to the half-life. So they are related by this formula that says the half-life equals the natural log of 2 over K. And the natural log of 2 is about equal to 0.693. So we can say 0.693 over K. And so from that, we can get this equation. K equals 0.693 over T1/2. And so for this, we get 0.693 over 5,700 years. And that equals 1.2 times 10 to the -4 years to the -1. So now we've sort of fleshed out the basics of this rate business for the decay of carbon-14. So we want to sort of figure out what we can do with it. So one assumption I'm going to make, or maybe not an assumption, but more like a generalization, is that we're going to call the number of carbon-14 atoms n. That's just going to simplify things. And so let's go ahead with a sort of example problem. So if we start with 1 kilogram of carbon-14, we can ask ourselves, what is the rate of decay? So for this, we're going to use the differential rate law. And differential rate law, again, says, and this is with my little simplification, negative dn dt equals k times n. So the first thing we need to do before we can set out to solve this problem is we need to convert the number of kilograms of carbon-14 to a number of atoms, because for nuclear decay, the reaction rate is expressed in, in terms of atoms. So we start with 1 kilogram, and we just do some fancy stoichiometry, well, it's not that fancy, to get the number of atoms. So 1 kilogram times 1,000 grams per kilogram times 1 mole over 14 grams. So we get 4.3 times 10 to the 25 atoms of carbon-14. And this equals n. So we want to find the rate, and so we say negative dn dt equals k times n. From the previous problem, we got that k is 1.2 times 10 to the negative 4th years to the negative 1, and this is multiplied by 4.3 times 10 to the 25th atoms. Now, this is all dandy and stuff, but most of the time we actually prefer to express nuclear decay in disintegrations per second, the number of atoms that are disintegrating each second. So we're going to convert years to seconds, and we get that the rate equals 2.4 times 10 to the 14th seconds to the negative 1. Because this is nuclear decay, we can also say that's 2.4 times 10 to the 14th disintegrations per second. Let's just talk about some other general concepts. So for nuclear decay only, the rate only depends on the original number of carbon-14 atoms. And then we might want to talk about some uses. So in sciences, we can use this for radioactive dating. And in medicine, we can use this for an H. pylori infection test. This is a bug that causes stomach ulcers and other digestive system issues. And finally, here is my works cited. And thank you very much for watching this video.